so let's move on to talking about tangent lines, and I'm going to start with a simple example. Suppose f of x is x cubed plus 2x squared minus x plus 2. And I've been asked to find the tangent line at x equal 3. So what we need is the equation of a line, the tangent line in particular. So what do we need to do that? We need a slope, and in this case the slope is going to be f prime at 3. That's the slope of the tangent line at the point 3. And what point is it at? It's going to be 3 comma f of 3. That's the x and y coordinates of the point on the curve, on the graph of f of x. Excuse me. So there's two forms that we can use, either y equals mx plus b or y equal mx minus a plus f of a. Now I'm guessing that you have worked with this, but you may not have ever seen or worked with this one. I really like this second one, and the reason for that is that you can quickly read off, now this is a constant, you notice it doesn't depend on x, and you can see if you were to multiply it out, you would get m times x minus m times a plus f of a. So this is what you would usually refer to as b. It's just been broken up into more structured pieces. The slope is easily read. It's just m. So the coefficient on this bracket is just m. But the nice thing about writing it in this way with the x minus a is that we know that if you set x equal to a, then x minus a is equal to 0. This piece disappears, and we immediately get that the point a comma f of a is on this line. So we know that it goes through the point of tangency that we're discussing. And it's just really easy to quickly check when you have it in that form. All right, so why don't you take a minute to think about and calculate what the equation of the tangent line being requested up here must be, and choose one of these. So I'll wait. Okay, so assuming you've stopped and done some calculations, I'll keep going here and let you know. So the correct answer here is y equal 38x minus 3 plus 44. So without actually going through these calculations, I can just read off this form here, and I can see that I must have found, when I did this calculation, that m was 38, a was 3, and f of a was 44. Okay, now if you didn't get those, go back and check. I'm pretty sure I got these numbers right, because these have been through a couple years of clicker questions with classes. Okay, so let's talk a little bit about tangent lines in general. So here's just a graph of the function f of x, some unspecified but curvy function in green, and the tangent line that we've drawn is in pink at the point a comma f of a, where the height of that point is f of a. So how do we get that? Well, if you choose any point on the curve, on the tangent line, it'll have coordinates x comma y, and I want the slope between any point on this curve and the point of tangency to match the slope of the tangent line at that point, because that's what I'm trying to calculate. So what I end up with is y minus f of a, which is the rise in this function, and then I divide through by x minus a, which is the run in this function, and I force that to be equal to the slope at a. Okay, and now I can multiply through by x minus a, and then add f of a, bringing this over to the other side, and I get y equal f prime of a, this is the slope, often called m. Here's the rest of the form, x minus a and plus f of a. Now you can multiply that through and see the form you're probably more used to, which is mx, and if I include that minus sign, this is like b. Okay, so you could rewrite it that way if you like, but I find this is a much more useful way to write it, and I also find it a lot easier to mark. So you can make the marker's life easier as well by leaving it in that form. All right. So if x equal a, then y is equal to f of a. So the line goes through a comma f of a. It also has a slope f prime. All this whole sentence is just easily confirmed by looking at this expression here. Okay, so what is a tangent line to sine of x at x equals 0? Now you'll remember in class I showed an example of zooming in on a graph of sine of x, and we found that the slope of sine of x at x equals 0 is 1. That was last week in class. If you're watching this on Monday, maybe 2 weeks ago. Maybe last week. Yeah. Okay, so here's a general expression for the tangent line. So what I want you to do is look over these options and choose which one you think is the correct expression for the tangent line. Okay, so let me make a few comments now that I hope you've made your decision. The first one, it sort of formally looks close to correct. You can see here this is the derivative of sine of x, and I've multiplied it by x minus 0, and then added sine of x, which is the function itself. And that looks like f prime of a times x minus a plus f of a, where a is equal to 0 and f of x is equal to sine x. The problem is that this is supposed to be a and a, not x. And so when I leave the x here and here, this is no longer the equation of a straight line. This is the equation of x times cosine x, which is a complicated oscillating function, plus another oscillating function. And that's because I have not picked a fixed x value, in which case, in our case it should be 0. We've left it as a varying one. And so this is not the equation of a tangent line. And so that is not going to be the correct answer, even though it has almost the right form. Okay, y equals x, that actually is the correct answer. This one is just off by pi over 2. And then here, this is actually a general expression for the tangent line at any point x naught, but we were interested in the particular case of x naught equals 0. So this is, while correct, it's only correct if we choose an x naught equal to 0. Okay. So that's the correct one there, y equal x. Okay, so general case. So what I'm talking about here is the whole family of problems that we call tangent line problems. Now I mentioned this earlier in the term, and I want to emphasize it again. Some people will think of tangent line problems as coming in many different forms. So you have maybe 10 or 20 or who knows how many possible tangent line problems. So calculate the tangent line, or here's a tangent line, what must be the point of tangency, or all sorts of different ways of phrasing that question. If you think about each of these different ways of asking a tangent line question as a separate question, a separate type of question, you're missing the sort of generality or the big picture. So I want you to think instead of the relationship between all of these types of questions. So these all tangent line questions will have a function involved. They'll be concerned with a point of tangency. There's got to be a slope at the point of tangency, and then there's an equation for the tangent line. Now, it's possible that you get just 1 and 2, and from that you just directly calculate 3 and then 4, and that's what we did in the example just before. But I could also give you a case where I give you the function, but I don't tell you the point of tangency, but I do tell you the slope, and you have to actually find the point of tangency. And even though you might think of this as a different type of problem, I want you to see the relationship between this one and the others. It's sort of like you have to be given 2 things out of this list of 4, and you can get the rest. So if you're given the first 2, you can calculate the third and fourth. If you're given the first and the third, you can calculate the second and the fourth. And so they're all related in that way. Some piece of information is given, some is missing, and you've got to fill in the blanks. And that is the sort of general view of tangent lines. Okay, here's a slightly harder problem. Let f of x equal the same function, x cubed plus 2x squared minus x plus 3, and I want to find the tangent line parallel to y equal minus x plus 3. So this is actually one of the second types that I just described on the last slide. So here are the three things. What are we given? We're given a function of x, that's above there. We're not given the point of tangency. We're not exactly given the slope at the point of tangency, but we're given a line parallel to it from which we can extract a slope, right? A parallel line has to have the same slope, and here the slope is equal to minus 1, so the slope that we're interested in must be minus 1. So that we're given, and now we have to calculate the other two. So we need to find, so here's a multiple choice for you, clicker question. So we need to find which of these three things. Okay, let's see. So we need to find an a such that f of a equal minus a plus 3. We need to find a such that f prime of a is equal to minus 1, or we need to solve this equation here. Now, so let's see, the correct answer here is the second one. This one is exactly what I kind of alluded to. This equation here is the equation of a line parallel to the one we're interested in. And the slope of this line is minus 1. So the slope of the function we're looking for must also be minus 1. And that's what this says here, that f of a, where we don't know yet what a is, but let's say we knew what it is, f prime of a would have to be minus 1 to satisfy this parallel condition. What is this one here? This equation is forcing f of a to be equal to minus a plus 3. That means this function here, y equal minus a plus 3, or minus x plus 3, this would indicate that that line goes through the point of tangency, which is not what this problem says. This says this line is parallel to the tangent line. And then finally, this third option down here, this is actually the same as this one, except it's expressed in terms of x instead of a. You're just equating f of a with the parallel line. And so that's not particularly useful for this problem. All right, so solving that problem, so here's just the quick calculation. There actually are two answers. There are two values of a, and so why is that? So you can have, let's say we had a curve like this, and we have a line out here, and we're interested in finding the tangent line that's parallel to this line. Well, it turns out there's two. There's one there, and there's another one down there. Okay, so this is one of my a values, a1, and this might be the second one. And so you see I get 0 and minus 4 over 3. Now it just asks me to find a tangent line that's parallel to it, so I'm going to choose the one with the easier number, which is 0. And so I go through, and I encourage you to go through the calculation and figure out the equation of the line, but here it is. You should get minus x plus 2. So that's the end of what would be Monday's lecture, September 23rd. And I will see you all next class on Wednesday. And don't forget, you've got pre-lecture due Monday evening and Wednesday evening, and then a weekly web work assignment due on Thursday, and OSH 2 coming up on Friday.